We are still looking at the situation where volume is equal to 4/3 pi r cubed for a sphere, and we know dV and we're trying to find dr. We're going to take a slightly different approach in this case. Previously, what we did was we rearranged our function such that r was expressed in terms of v, and then went through some quite complicated algebra in order to find our dr. The technique we're going to use here is far simpler from an algebraic perspective, except sometimes students have a little more difficulty understanding the rationale for using this technique. We started by stating our function v is equal to 4/3 pi r cubed. Then we've stated our formula for differentials. dy is equal to f prime x dx. So if we take a look at our particular function and apply this formula, we would end up with dv is equal to 4 pi r squared dr. Now, we know that dv has to be within half a percentage of its true value. Therefore, we can say that the absolute value of dv is less than or equal to 0.005 v. We used absolute values because this particular error could be both positive as well as negative. So in the next line, what we've done is replaced v with 4/3 pi r cubed, because we know volume is equal to that. Then, in the third line, we know what dv is equal to. We just worked it out. dv is equal to 4 pi r squared dr. So we can substitute that in. So our third line reads the absolute value of 4 pi r squared dr is less than or equal to 0.005 times 4/3 pi r cubed. Remembering that what we're trying to do is solve for dr, we're going to divide both sides of this inequality by a 4 pi r squared, and that's what we've done. So dr is less than, the absolute value of dr is less than or equal to 0.005 times 4/3 pi r cubed, which is all divided by 4 pi r squared. Some of you may ask, well, don't I have to flip the inequality sign? Well, in this case, we don't have to worry about that, because since we're dealing with the situation of a sphere where our radius is going to be a positive number, therefore 4 pi r squared is also going to be a positive number, and dividing both sides of an inequality by a positive number does not require that you flip the inequality sign. So once we've done that, we end up with the absolute value of dr is less than or equal to 0.005 times 1/3 r, which is the absolute value of dr is less than or equal to 0.00166667 r. I've had to round that off. So what can we conclude by looking at this last line? That dr is less than or equal to 1.6667% of r, which is 1/6 of a percent of r. So r should be measured with an error of no more than 1/6 of a percent. This is the same answer that we obtained using the other method, but I think you would agree this technique is far simpler.